Hi, with section 1.5, we're talking about addition of real numbers. So the first thing we have here is what is the additive identity? Now you can see here it says recall from section 1.3 the multiplicative identity of 1. Remember, the multiplicative identity says if you take any number and multiply by 1, it doesn't change the identity. So now the additive identity is going to be the similar idea. We want to say A plus some number is going to be equal to A. And we want to say, okay, what can we fill in the blank with that? Right, so think of this. What can we put in that box that would make that true? Right, it's going to be a 0. So 0 is the additive identity, because it's the number that we can add to anything and it will not change its identity. So 0 is the additive, multiplicative is 1. So example 4, add. And we say use your calculators to check your answers. We have -2 plus a -3. So we want to think of it as if you're at a -2, you can think of a number line, and you subtract 3 more digits, right? Meaning you're moving to the left, you end up with a -5. Now we're going to go 2 plus 3. You're at a +2, you're adding 3 more, you're at a +5. Now what we want to look at is that we have -2 plus 3. So if we're at a -2 and we add 3 to it, right, we're left with a +1. And then lastly, if we're added 2 and we subtract 3, we're left with a -1. Now, we can kind of think of some rules here. With A and B, you'll notice that both of the digits, so here and here, are both negative, whereas in B, this one and this one are both positive. So if the signs are the same, we want to find the sum, meaning you want to add the two numbers together and keep whatever sign they are. So in this one, 2 plus 3 is 5, they're negative, make it negative. 2 plus 3 is 5, they're positive, keep it positive. Now in letter C and D, you can see that we have different signs. One's negative, one's positive. One's positive, one's negative. When the signs are different, so when the signs are different, we want to find the difference between them. Meaning, what's the difference between a 2 and a 3? A 1, correct. And then we know the sign because if the 3 is positive, that means it's bigger, your 1 should be positive. Here the 3 is negative, 3 is bigger than 2, so your answer is negative. Okay, example 5. First thing I want to warn you about on example 5 is you must show work. So this one, you must show work. You cannot just type it into your calculator, then write the answer down. So let's go ahead and start working through this. There's a couple ways you can approach it. What I'm going to do first is reorder this. Remember, we use the commutative property to reorder a sum. So I'm going to put all my positive values together. So we have 15, this would be equal, so 15 plus 7 plus 14. Now I'm going to add all my negatives. So -2 plus a -5 plus -12. Squeeze it in there. Now what we can do is add up all of our positives and add up all of our negatives. Again, remember, as long as they have the same sign, you can find the sum of these. The 14, the 15, and the 7 all have the same signs. So we take 15 plus 7 plus 14, and we get 36. Now we can add all these negative numbers. So -2 plus a -5 plus a -12. And when we do that, we get a -19. Now, since we have a positive and a negative, with positive 36 and -19, we want to find the difference between them, which means subtraction. And we get an answer of 17, and it's going to be positive since 36 bigger, and that is positive. Next page. This is where we're going to use this in problems. In December of 2018, the price of gasoline, or the price of a gallon of home heating oil was $2.84. Over the next 4 weeks, the price rose 1 cent, rose 3 cents, dropped 13 cents, and then dropped another 7 cents. What was the new price for a gallon of heating oil? Again, you must show some work. So we must show some work, meaning we have to set up an algebraic expression that represents what's going on here. So we're starting with $2.84. Now the first thing is it rose 1 cent, so we're going to add 1 cent. Now keep in mind, 1 cent is 0.01. It says it rose another 3 cents, so 0.03. Now it dropped 13. So we are going to add now this time a negative 13 cents. And then lastly, it dropped another 7 cents. So we're adding again a negative 0.07. Now some of you may have said, well, couldn't we just subtract these? Absolutely. And that's what we're looking at in the next section. But since this is still addition, we're going to set it up this way. So now what we need to do is evaluate this. So again, this is the step of work that you must show on the exam. I need to see what you are doing. So we take the $2.84 and we add 0.01, add 0.03, add the negative 0.13, and then add the negative 0.07. So therefore, the new price, oops, let's do this in blue. When we calculate this, the new price is $2.68 for the price of gas. You don't have to show all the work of this. What I'm looking for is that you're able to translate this to an algebraic expression. You could have worked through how we did the previous one and combined these two and these three and then combined everything together. That works as well. The last idea we have here is combining like terms. And this tells us the distributive law enables us to combine like terms. Now, a lot of you probably can look at negative 7x plus 9x and just think, oh, easy, that's 2x. That's perfect. But I'm going to show you why that works. So if we think back, I'm going to move around the side here and do some side work. If we have 2x plus 10, and I tell you to factor this is coming from one of the earlier sections. We notice that each of those has a factor of 2. So it's 2 times x plus 2 times 5. Now what we could do here is factor a 2 out of both of those and create 2 times x plus 5. Everyone remember that idea. Now we can do the same thing over here. We will notice that each of these terms have a factor of an x. They both have an x. So we could factor the x out of this. So we could factor the x out and be left with negative 7 plus 9. Now continuing to simplify, we'd have x and then negative 7 plus 9, right, would be a positive 2. X times 2 is 2x. That would be the commutative property by changing the order of that. Now, you don't have to do that every time. I'm just showing you why it works. What we're doing is just looking at the coefficients. Whenever you have like terms, meaning the same variable, you look at their coefficients and you add or subtract those. So negative 7 plus 9 is 2, and then you bring down the x. So now let's look at this last one. We have 2a plus a negative 3b plus a negative 5a plus a 9b. So you can see that we have two terms that have an a, and we have two terms that have a b. What I'm going to do first is use the commutative property and reorder it so my like terms are next to each other. And then I'm going to add the negative 3b plus the 9b. Now we want to combine the ones that have the same variable. 2 plus a negative 5, right? That's negative 3a. And then we're going to add it to a negative 3b plus 9b. So negative 3 plus 9, right, is going to be 6b. And that would be our final answer. That's all we have for this video. So please, if you have any questions, feel free to reach out.